Welcome to Your Dose of Wowness.
All right, for our big Week 4 recap, we're going to switch things up. This past week, we've jumped headfirst into some of the wildest, most mind-bending questions in all of cosmology. And now, we're going to rank them.
We started by asking that chilling question, where is everybody? Staring right into the heart of the Fermi Paradox, that deep, unsettling quiet in a cosmos we think should be shouting with life. Then, we tuned our ears to the stars and heard the wow signal, just a 72-second whisper from the void, caught way back in 1977, and then total silence. It has never been heard from again.
We also went hunting for the universe's ghost, dark matter, that invisible stuff that's holding entire galaxies together, making up a huge chunk of everything, yet we can't see it, touch it, or find a single particle of it.
And remember our first visitor from another star system? Yeah, Oumuamua, the thing that came tumbling through our cosmic neighborhood and then hit the gas on its way out. It accelerated, and we still have no solid idea why.
We looked at the very fabric of reality and asked, is this whole thing a setup? Why do the laws of physics seem so perfectly, almost impossibly, calibrated to allow for life, for us to exist? And to top it all off, we faced the biggest question of them all. Is any of this even real? We dove into the simulation hypothesis, that wild idea that our entire reality might just be, a program running on some cosmic computer.
Okay, so that's 6 colossal questions, right? But here's the thing, they are not all created equal. Some of these mysteries, they're really just data problems. We're on the verge of solving them. But others, man, they might be completely beyond our reach, forever. So today, we're ranking them. We're creating a cosmic leaderboard from the mysteries we can probably crack to the ones that might just be impossible.
All right, let's get into it. We're starting with the most solvable stuff, the problems that are really just waiting for the right piece of tech or a flood of new data to fall into place. So, kicking things off at number 6, the most solvable cosmic mystery on our entire list is dark matter.
I know, that might sound totally backwards, right? How can something we've literally never ever seen be the easiest to solve? Well, it's because while we can't see the thing itself, we can see what it does. We see its shadow, its gravitational footprint all over the universe. It's the invisible glue holding it all together.
And the proof is it's overwhelming. You look at how galaxies spin, they're moving way too fast. You look at how light bends around galaxy clusters, something massive and invisible is warping spacetime. The evidence is everywhere. So this really just boils down to a detection problem. We are so sure it's there, we've built these incredibly complex, sensitive traps deep underground, just waiting for a dark matter particle to wander in. We haven't nabbed one yet, but for most scientists, it's really just a matter of time.
Okay, moving up the list to number 5. And here we've got our mysterious interstellar guest, Oumuamua. Now this one feels way more mysterious, doesn't it? It was this bizarre, cigar-shaped thing tumbling through space. But the real kicker was that it accelerated on its way out, like it stepped on the gas. But there was no engine, no comet tail, nothing. Just this ghostly push.
So why is this considered pretty solvable? It's simple, really. The problem with Oumuamua isn't how weird it was. It's that it was the only one we'd ever seen. Our sample size was exactly 1. But that is all about to change in a big way. We've got new observatories coming online, like the Vera Rubin Observatory, and they're expected to spot dozens of these interstellar travelers every single year. So the solution isn't about chasing Oumuamua, it's long gone. It's about seeing the next 20, the next 100, and figuring out what's normal and what's truly strange.
Okay, we're climbing the ladder of impossibility now. The next set of mysteries aren't about waiting for new data to show up. They're defined by what's not there, by the information that's completely, frustratingly missing.
And this slide just nails the difference, doesn't it? You've got the wow signal, that's the presence of a single unexplained piece of evidence, a 72-second blip that screams, "What was that?" Then you've got the Fermi Paradox, which is the exact opposite. It's the profound absence of any evidence at all, when there should be tons. One is a mysterious footprint in the sand, the other is a completely empty beach that stretches on forever.
So, coming in at number 4 is the wow signal. Now, why is this tougher than Oumuamua? Because with Oumuamua, we can just wait for more visitors. With the wow signal, it was a one-and-done event. A single 72-second shout into the void that happened decades ago, and we've been straining to hear it again ever since. And that brings us to number 3, the even deeper, more profound mystery of the Fermi Paradox. Why is this so much harder? Well, think about it. To solve the wow signal, you just need one explanation for one 72-second event. To solve the Fermi Paradox, you have to explain the silence of the entire 13.8 billion-year-old universe. The scale of the problem is just staggering.
Okay, now we're at the summit, the top 2. And here we leave the realm of normal science. These aren't just questions about data or detection anymore. These questions poke at the very fabric of reality, pushing the absolute limits of what we can even hope to test.
And the runner-up for the most impossible mystery to solve is this: the fine-tuned universe.
This isn't about one weird object or one missing signal. This is about the rule book for the entire game. I mean, look at this number. If the force of gravity was just a tiny, tiny fraction stronger or weaker, stars would never form, or they'd burn out instantly. No stars, no planets, no life. It's like all the dials of the universe were set to the exact right numbers for us to be here and ask the question. So, how do you solve that? How do you test it? You'd have to go find another universe with different rules, and, well, that's probably not happening anytime soon.
And so, here we are. Number 1. The single most profound, the most unsettling, and yes, the most impossible cosmic mystery we have ever looked at: simulation theory.
So, what makes this the king of impossible questions? It's because it's a perfect trap. Think about it. Any test you could possibly design, any piece of evidence you could find to prove you're not in a simulation, could just be another line of code in the simulation itself. If the program is good enough, there is literally no way to know you're inside it. It doesn't just question what's in our universe, it questions the very nature of the universe itself.
You know, after going through all this, you start to wonder, it's not just about what we can solve, is it? It's also about the mystery itself. Maybe some answers would actually make the cosmos a little less magical. So I want to leave you with a different kind of question tonight. Which one of these mysteries do you actually hope we never figure out?
What a week! This stuff is seriously mind-bending. And honestly, it's your curiosity that fuels this whole journey. So thank you, truly, for joining us as we explore the very edge of what we know and what we don't. It's been a blast.